Hi there, my name is Derek Chang, and in this video I will solve video problem 1. I will show both a geometric and algebraic argument for why two vectors can span R2, and I will also discuss a case involving spanning in R3. Here I have drawn two vectors v1 and v2 on the coordinate plane. Notice that these two vectors are not parallel, they point in different directions. When two vectors in R2 are not parallel, they can span the entire plane. That means any xy point can be reached by moving some amount of v1 and some amount along v2. For example, this. Or if you were to go in the negative, you could do, whoops. If you go in the negative here, then you can bring this here to go anywhere along here, or you bring it negative as well. And with this, you can get across to any point along the plane. Thus, geometrically, since v1 and v2 are not parallel, they can span the entire plane R2. Now let's make an algebraic argument. We want to show that any point can be expressed as a linear combination of v1 and v2. So first I'm going to set up the linear combination. 3, 1 plus b 1, 2 equals x and y. And from this we can lead to this system. 3a plus b equals x, and a plus 2b equals y. We can solve for a and b in terms of x and y. So from the second equation, and by substituting into the first equation, with b equaling 3y minus x over 5. And then we substitute back to solve for a. And since for any xy point we can find real numbers for a and b that satisfies these equations, it shows that in the span of v1 and v2, it is for all of R2. And finally, moving on to part 3. So now in R3, we are given the three vectors here. v1, v2, and v3. With these three vectors, we found that we can always return to home, meaning we can't get back to the origin. However, we cannot reach every point in R3. The problem is that these vectors are most likely linear dependent. That means one vector can be written as a combination of the others. In order to span all of R3, we need three linearly independent vectors. Linear independence means that no vector is a combination of the others. Therefore, it is possible to replace one of the current vectors with a new vector that is independent of the others. If we can do that, and the three vectors become linear independent, then we would be able to reach any location in R3. In short, the new mode of transportation would need to make the set span R3 by being linearly independent from the others. So thank you for watching my video for video problem 1. I hope this explanation was clear and helpful. Have a great day.